Hello, thank you for watching this video. So in this video, we're doing question 5 of November 2024 question paper mathematics paper 2, and the topic is trigonometry, as you can see here. So we'll be applying some trigonometric principles. So let's go. Actually, before we start this question, if you're interested in attending our online sessions and you think you find our videos helpful, so you can attend our classes and look at more information on the description. You will also see our contacts there, so we can talk and see if our sessions will work for you. So let's start with the question. They are saying in the diagram, line OP is given with P having coordinates -3 and -4. They are saying angle O, which is between KO and OP, is equal to A. So here you are given here in this diagram the line OP, right? And you're told that the coordinates of P is -3 and -4. They are saying that angle O, which is the angle between KO and OP, is equal to A. So this angle here is A. So from the positive axis is anti-clockwise to OP, the measure of that angle is A. That's what they're saying. No problem. What else do we have? So now that's all we have really. So the next question, which is 5.1.1, they're saying determine without using a calculator the value of cos A. So at 5.1.1, they want the value of what? Of cos A without using a calculator, right? So they wanted to find cos A. So if you're given a situation like this, as you might know by now, the first thing that you need to do is to draw a line from the end point of the line that starts from the origin and join it to the x-axis, right? So if this line was here, you're going to join it there. If there was a line here, you're going to join it down here. If there was a line down here, you join it down here. So what you do, you join this point by a vertical line to your x-axis, right? So if this is vertical, so this angle here is 90 degrees, right? So if it was here, you will join it down. If it was there, you join it down. If you're down here, you join it up here. That's the first thing that you do. Once you do this, as you need to understand now, this is the x coordinate, right? And it's -3. So which means the x coordinate of this point is -3, right? So the x coordinate there is -3. And the y coordinate is what? Is -4. So which means what we have here is what? Is -4. That's what we have. So the length, this side is -4 units down. So this length is -4 units down from the x-axis, right? And you can say this side here is -3 because you know that the y value there is -3. So this side is 3 units. So from there to there is -3 units. That's the first thing that you have to do. Now, if you're looking at this triangle, you have a right angle triangle here. You have this horizontal, this side and this side. On this right angle triangle, you're missing the hypotenuse. So what you need to do, you need to fill this triangle completely so that you have all the sides of that triangle. So if you have a right angle triangle and you're missing one side, you can use Pythagoras theorem, right? So what is your Pythagoras? Say your hypotenuse squared equal to x squared plus y squared. So this is Pythagoras, right? Fine. What is your hypotenuse squared? It's what we're looking for, r. So r squared is equal to x squared. What is your x squared? X squared is that horizontal distance, which is your x here, which is -3 all squared, plus y squared, which is your y is -4, which is this length over here, because the side of this triangle. So -4 all squared. So this is 16 and 9, right? 16 and 9, they add up to 25. So if you take the square root of both sides, so you have r squared is equal to 25. If you take the square root of this side and the square root of this side, you get that your r is equal to 5 units. So we get that this side is equal to 5 units. So we have a complete triangle, right? So if you're looking for cos A, it's going to be easy now. So okay, for us to find cos A, what is cos? So cos is equal to the adjacent side over the hypotenuse side, right? You know that by now. Then, what is the adjacent side? So adjacent side is this one, right? Over here. So it's minus 3 over the hypotenuse side, which is this side over here on this triangle. So we're looking at this triangle over here, over 5. So this is your cos A. And you're done with 5.1.1. Now we move to 5.1.2. What do they want at 5.1.2? At 5.1.2, they want cos2A. At 5.1.2, they want cos2A. So they want us to find the value of this. So, how do we find this? You know this is a double angle. So you have it on the formula sheet at the back. So you know if you have cos2A, there are 3 options. It is equal to cos squared A minus sine squared A, right? Or you can say this is equal to 1 minus 2 sine squared A, or this is 2 cos squared A minus 1. Any of the 3 will work. Any of these 3 will do the work. But if you look at what you have, because I already have cos A to be that, so if I say 2 times cos A all squared minus 1, it's going to be easy, right? So you can say, okay, my cos2A, out of all this, I'll take this one because I already have cos A to be that. So I'll say it's equal to 2 cos squared A. So I'm going minus 1. So I'm going to take this identity here because this is equivalent to that. So when you're saying this is equivalent to that, they are not the same, right? They are equivalent. They are not the same. So in that case, so okay, this is equal to 2. This is cos A all squared. What is your cos A? Your cos A is that, which is your minus 3 over 5 all squared minus 1. Therefore, your cos 2A is equal to the answer to this. So let's punch that on our calculator and see what the answer is. I can't see my calculator right now. So if you punch this, going to be minus 3 minus 5 all squared minus 1. You get that the cos 2A is equal to minus 7 over 25. This is your cos 2A. You could have used any of these identities. It would have worked exactly the same. Or let's say you could have used this one. So you can say, okay, my cos 2A is equal to 1 minus 2 sine squared A, which is 1 minus 2. What is your sine squared? What is your sine squared? So it's 1 minus 2 times sine squared. Go and look for sine squared A there. If you're looking for sine squared A, sine is called the opposite side over the hypotenuse. So if you had A, the opposite side is minus 4, your hypotenuse is 5. So what you have here is minus 4 over 5. So punch this in your calculator, you have 1 minus 2 into minus 4 over 5 all squared, right? So this comes out to be minus 7 over 25. So this is the same thing. You could have used this one as well. You can do it yourself because your cos squared, your cos A is equal to what? Is that, then you squared. And your sine A is equal to this and you squared. It should come out to that. So it should work in any way. Any of those identities, they work the same way or in a similar way. So we're done with 5.1.2. Now we move to 5.1.3. Okay, so I'm done writing 5.1.3. So what are they saying? They are saying determine without using the calculator the value of sine A minus B. So they want you to find the value of sine A minus B, right? If what? If it is given that sine B is equal to 4 over 5 and your B is more than 90 but less than 360, right? No problem. So what they're telling you, they want you to find the value of sine B, sorry, of sine A minus B. If what? If they wanted to find the value of sine A minus B. If it is given that your sine B is equal to 4 over 5 and your B is more than 90 but less than 360. That's what you're given. So how do we go about this? So first you need to understand this, what this is. This is a compound angle, right? So you can see from the back of the formula sheet that sine A minus B is equal to what? It's equal to sine A times cos B, right? Minus sine B times cos A. That's what it is. It is something like this. So we can look for sine A from that diagram. Cos B, we don't have it anywhere. Sine B, we know what it is, 4 over 5. Cos A, we can look for it over there, right? But sine B is the only thing that we seem not to know. Seems like we don't know what sine B is. Okay, so how do we go about this? You know that sine theta is equal to the opposite side over the hypotenuse side, right? Fine. So what you have here, you are given an angle that is more than 90 but less than 360. So the angle B is more than 90 but less than 360. So which means it starts from here and it's after this, after 90, but it's between, it can be anywhere between 90 and 360. So if you measure it here, B, it can be anywhere between 90 and 360, anywhere between these two quadrants. That's what they're telling us. So if we want to draw something like this for this triangle, for this trig ratio here, first we know that it will be on this quadrant, or this quadrant, because the B, which is an angle B, is more than 90 but less than 360. So it's between these three quadrants there. But now what you need to understand is that because the sine B is positive, between these two quadrants, between these three quadrants that it is possibly sitting at, sine on that quadrant needs to be positive, right? So sine B is this angle B between 90 and 360 is in a quadrant where sine is positive. And you know that here on the first quadrant, all your functions are positive. Here, only sine theta is positive, right? Here, only tan theta is positive, and there, only cos theta is positive. So, we said B is between second, third, and fourth quadrant. And we're saying because this ratio is positive, sine itself needs to be positive, because this is equal to sine B. So which means sine B itself needs to be positive. And that between these three quadrants, sine is only positive in the second quadrant. So what does that mean? It means sine of beta is on the second quadrant. So we need to draw a triangle similar to this one on the second quadrant, right? And that triangle of yours, we said sine is equal to the opposite of a hypotenuse, right? So what does that mean? It means your sine B is also equal to what? Your opposite over hypotenuse, right? Which is equal to what? Your 4 over 5. So in that case, you need to draw a line similar to this one, but on the second quadrant. So I'm going to draw with a right move. So I'll have a line like this. You can put it there, right? Fine. The opposite, which means my B starts from here and ends there. So this is my B. Because B is between 90 and 360. And on the quadrant where sine is what? Where sine is positive. And sine is positive where? On the second quadrant. So this is our B. Fine. In that case, you do the same thing. You complete your triangle. Maybe you draw it down here. Here we go. And you know that sine is called the opposite, right? Over hypotenuse. And your opposite is 4 and the hypotenuse is 5. In that case, Your opposite is what? Your opposite is this. So you have 4 here. And the hypotenuse is what? It's 5, which is this one. What you don't have now is the adjacent side. But look at this triangle. These are 2 triangles. This triangle and this triangle. These triangles are identical. They're congruent. So this minus 3 works for both of them. So if you use the Pythagoras, you will find the minus 3 still. Because look, the height is 4. That height is 4. This one is this. And this one is that. So this triangle are congruent. So these are exactly the same triangles. So it will be minus 3 there as well. So this minus 3 works for this triangle and it works for that triangle as well. So I don't need to find that. So if now I'm asked to find sine A minus B, I said this is equal to sine A times cos B minus sine B times cos A. So in that case, what do you have? Sine A minus B is equal to sine A. What is your sine A? Go to a triangle A. So here's angle A. Sine A is called opposite over hypotenuse. So it's minus 4 over 5. So what you have here is minus 4 over 5. What is your cos B? Cos B, come and look at cos B here, right? So your cos B is equal to, this is our B. So if you're looking, our cos B is equal to adjacent, which is minus 3 over hypotenuse, which is 5. So on this triangle, this is your adjacent and that is your hypotenuse. So it's minus 3 over 5 minus what? Sine B. Let's go and look for sine B. Sine B is what we're given. It's minus 4 over 5. Or you can look for it. It's the opposite side over the hypotenuse. So it's 4 over 5. 4 over 5 times cos A. What is your cos A? Your cos A is what you found at the beginning. Here is it. Or you can look for it. Your angle A is this one here. So your cos A equal to adjacent, which is minus 3 over 5, which is same as this. So you have minus 3 over 5 here. So you punch it and see that your sine A minus B is equal to the answer to that. So what do we get? Let me punch it. So I'll say, okay, minus 4 over 5 times minus 3 over 5 minus negative 4 over 5. Oh, sorry, not negative 4, just 4 over 5 times negative 3 over 5. The answer you get that sine A minus B is equal to 24 over 25. And that's how I think this question is done. I'm done with 5.1. I'm going to clean the board and do 5.2. So let's clean the board. Okay, so now we're doing 5.2. At 5.2, they're saying if cos alpha is equal to P, express the following expression in terms of P. So at 5.2, we're given that cos alpha is equal to P, right? So they want us to express this expression in terms of P. No problem. So what do we do here? And in order to do this, you need to be familiar with your compound angles and your double angle identities. So this looks like a double angle identity. So just think of this. At the back, you'll find sine 2A, right? The sine 2A is equal to 2 sine A times cos A. So you see this angle and this angle are the same. This sine and cos are multiplying each other. So this and this looks like that. You can see your cos and your sine are multiplying each other. The only thing that is missing is this. Is where you're missing your 2, right? So which means you can maybe divide by 2. So sine over 2A, which is 2 times those angles that are there, all over 2 is equal to what? It's equal to sine. Equal to what? Sine A times cos A. So this and that went away, of course. So if you look at this and this, it's similar to this one and this one over here, right? And if you're looking now, this is equal to this thing, which is sine 2 times those angles that are there. So what you see over there is this, right? Is this times this, which is equal to that. So instead of having this, we can try to write these two this way, if that makes sense. So what I'm going to do, I'm going to say, okay, let's have what? This side. Instead of having these two, we can just have the sine and double those two angles. And double A, so I'll have sine 2A angle A. So in this case, I don't have A, my A is this thing, so I'll just have sine 2 times my angle A, but my angle A this time is these two things. So it's A alpha over 2 minus 45, right? This is all over what? This is all over 2. This 2 is this one over here, right? Not that one over there. So this is sine 2A over 2, which is sine 2 this angle over 2. So you also need to write this one. So just say maybe divide by 2, because I don't want to have a lot of divisions. That can be very confusing. So you can try to simplify this. If you try to simplify it, you have sine into 2 times alpha over 2. It will just be 2 alpha. It will be 2 alpha, right? Over 2. 2 times 45 minus 90. All over 2, of course. Divided by your 2. So what you have sine alpha minus 90 all over 2 divided by 2, right? So this is not A, this is alpha, of course. So in simple terms, what you have there, you have sine negative 90 plus your alpha all over 2 divided by 2, of course. So you know that if you have your maximum, which is the number that sits here next to 45, next to sine, if this maximum is negative, you add 360 to it so that it becomes positive. So what you will have sine of negative 90, you add 360 to it. Then your alpha all over 2 divided by 2. So what you have, if you add that, you will have sine of 270 plus alpha all over 2 divide by 2. In that case, to start asking yourself questions. Where is 270 plus? 270 plus is on the 4th quadrant, right? 270 plus, let me just do that thing. Let me just have it here. So I have 0, I have 90, I have 180, I have 270, and I have 360 here. So the values of theta are acute angles. They are less than 90 and more than 0 degrees. So all the values are here. They are less than 90. So if you minus theta on 90, it will fall in the 1st quadrant. If you add theta on 90, which is if you add an acute angle on 90, it will be on the 2nd quadrant. If you subtract an acute angle on 180, it will be on the 2nd quadrant. On 180, if you add an acute angle, it will be on the 3rd quadrant. If you subtract 270, if you subtract an acute angle from 270, it will be on the 3rd quadrant, right? If you add an acute angle to this 270, it will be on the 4th quadrant. If you subtract an acute angle to 360, it will be here, right? And you need to remember that on the 1st quadrant, right, all your trig ratios are positive. Your sine, your cos, your tan are all positive there. Then here on the 2nd quadrant, only sine theta is positive. On the 3rd quadrant, only tan theta is positive. On the 4th quadrant, only cosine of theta is positive. So, if I'm asking where is 270 plus, 270 plus, you can see it is on the 4th quadrant. 270 plus is on this quadrant, it's on the 4th quadrant, because this is 270 plus theta. Because if you add theta on an acute angle on 270 will fall here. So in that case, where is 270 plus? It's on the fourth quadrant. What sign is the trig ratio here? The trig ratio is negative, right? And what you need to remember now, this trig ratio is negative on that quadrant. So what you need to keep in mind is that if the maximum lies on this vertical line, which is either 90 or 270, your function will change to its co-function identity. So if you have sine, it will become cos. If you have cos, it will become sine, right? So you had cos here, and the maximum 270 falls on this vertical line. So it will change and become cos what? Cos alpha all over 2. Divide by 2. Then the only thing that you have to do, change this to a multiplication sign. So it will become what? Negative cos alpha all over 2 times, this is over 1, so it will be times 1 over 2. So this is called negative cos alpha over 1 times this, negative cos alpha, 2 times 2, it's all over 4. So you have negative cos alpha, and you're told that cos alpha is called p. So this is negative p over 4 of some sort. So this could have been much shorter, but I tried to explain all the steps, and I'm sorry if you're annoyed by how slow I was. And I'm done with this question here. And again, if you want to attend our online sessions, you can find more information on the description below. And I hope this question 5 did make sense to you as it does to me. And thank you for watching. Cheers.